Hello, good evening, everyone. Uh, Once again, we are starting a webinar. This webinar we are starting earlier. We were supposed to do it on Saturday, but we doing this today on a Wednesday because a few of the students are already implementing the second project, which is very nice. And congratulations to you. And they require some help of the some challenges of the second project, which is comprehensible. So I'm doing this webinar earlier so we can get to those topics. And by the end of this webinar, I believe you'll be able to do almost everything from the second project. We even begin to explain the second part. The second part is pretty nice. Pretty nice, nice command line interface program. So you'll be using the command line to execute the program. It will take some arguments from the command line itself, and you'll be able to use those everything we developed so far. So let's get going because we have a lot of ground to cover today. So let me share my screen with you. Not this. So here we are. Let's go a little bit back and let's see what we have imported by now. So by now I have to import all of these libraries. As a new library, I have to import Seaborn. We will be using Seaborn for plotting. Seaborn is a wrap around the matplotlib, which makes plotting much easier and the plots looks much better. So we will be using Stillborn for plotting the by the end of the lesson. So yes, we have to plot matplotlib and we have to plot Seaborn. We have to import Peel from the last lecture. So far we have defined our transformations, define a model, a classifier. We have defined the function for checking for accuracy and the function for doing the deep learning training. And we have done the training. We have defined criteria and optimizer. And don't mind this error. This is because I was trying to execute this line without defining my model. But don't worry, this is should not happen to you if you execute all these lines. Then we have done the training here. What else? We use this function to do the training, and then we have saved. I changed this because I had not defined a function for save the model. It's much better to use a function, so I just create this function. This function just saves the model. It's basically there's nothing new here, so we give a model, a file name to the checkpoint, and class to AJX to attach to the model. I'm attaching it to the model and saving the model and creating a file with the file name provided. I'm using this function here. So as you can see, this is my name. There's a typo here, don't worry. I was about to say my checkpoint, I forgot the T, but don't worry, it doesn't change anything for us. And I provide a class to IDX, and I also define this load model function because it will be much helpful to us to use this function. It takes a checkpoint, loads a model, and loads the state for that model. I'm using it here just for testing. And we did this process imaging it's on the past webinar. and we create this process image function for processing our images that we take from using Peel. That's why we are loading Peel. And don't forget to add Peel here and Seaborn here, otherwise your code will not work. So this function was already given to us to show the image that this function creates. Process an image, and this one shows the image that was processed by this function. So you basically feed this one up an image, and this one will show for you. And now we are here. We are about to create this function. I'm not going to code it once again because coding live actually takes a lot of time, and we actually need this time to explain more things about this about the second project. So I'm just going to explain to you. Well, what this function does is exactly what the one that we're requesting from you. I'm sorry, it's not here. The one that was requested from you does. It takes an image path. A checkpoint. This will be a checkpoint, and basically it does the prediction. So let's go line by line. So first we have the signature of the function. It takes an image, a saved model, and how many classes do you want to show the prediction for the model. For example, the model will predict for that one of your flowers that you give it to predict may predicted. Well, this flower could be I'm 60% sure that this flower is this one, and I'm 20% sure that will be this one the wrong one, and this one, and this number just tells you how many of these you wanna give. Basically, you can give anything from 1 to 102, I believe, the maximum, the number of categories. I'm doing this test on this project on the cat and dogs data, so all I have is two classes. I'm already telling it to show me how much it thinks that this image is a cat and how much it thinks that this image is a dog. So I have two. So basically, we use our define function, a load function that was defined here. Sorry. To my sharing, so just wasn't sure. That's okay. Sorry. We are loading the model and loading a training model. Now we're gonna set the model to evaluation mode. This will be just we're telling the model that we're not gonna train, so it can set itself up just for doing a prediction. So we're gonna evaluate the model, use this line, and now we process the image. We use the function we defined to process images. And here we have to convert that image into a tensor, because this process image will actually give you a NumPy array of the values for the colors on the pixels. So we have to transform that to a tensor. We do this with this function here. Choose this pytorch expense gene within the process image x equals 0, and sets it to a float tensor and sends it to CPU. And now we are passing the model, passing the image, this tensor to the model, and getting the probabilities, the predictions. And but since we're using logmax function, or at least I am using logmax the log softmax function. This will give you a log probability. So how to do? You have to do an exponential with the probabilities to get the linear, to get back to linear probability. So we do that here. Then we use this top k method that the documentation told us about. How many classes do you gonna get predictions? I'm getting 2 by default, but I can change this to 1 if I wanted to. And got top probability and top labels. We detach everything, just one of the probabilities in the labels. That's why we use this detach method. And here we are reversing the dictionary that the documentation said we should. The dictionary is the one that we attach to our model. When we attach class IDX to our model, there's a dictionary, and we're getting the items. And then we are doing this comprehension for loop. It's actually a for loop, one line for loop, but you can actually do this one with a normal for loop, and doing a loop through this with the key and the value for the key on the dictionary, and starting to a dictionary. This is a list comprehension. This is much cleaner code, and if you're not used to this code, it's just a for loop, and you can look there online if you want to. And once again, we're getting the top labels for the just doing a loop once again, one line loop inside the top labels that we just got here. And we are returning the top probabilities and the top labels. And pretty much this is our function. Let me send it to, this is our prediction function. And from now on, we basically did all the predictions, and we can do the testing. So here I have 2 images that are on the Udacity workspace. You can, if you're wondering where I got these images, I can go to File, Open, and this will send me to the workspace. I'm on this workspace. As you can see, I'm on this notebook. And if I go inside this folder, and inside this folder, this is one of the images I'm using. I'm giving the mod this address to the model to the prediction. Let me go back to where we were, and this is an image of a cat. This is an image of a dog, and I want to do the testing on the first image. As you can see, I'm just using index to get this string and pass it through the model, doing the predictions, obtaining what we got here, the top probabilities and top labels. And here I'm just getting the title. I'm setting the figure size, the size of the pouch that I want from matplotlib to 16 by 16, which is this size here. And what I'm doing here, I'm gonna do a sweep plot. What I'm gonna do is I'm gonna have basically 2 plots, one on the top of another. So this is what I say, this is one on top of another, 2 plots on top of another here, and just one plot by the side of the other. So just one plot by we'll say on the x-axis, just one plot, and this will be the first plot. And this first plot I'm doing is I'm using image show. As you can see, image show actually is plotting the image using matplotlib. See, so it is matplotlib. This will be my first plot. And then I'm resetting the figure size to be smaller to do the second plot, and I'm setting the second plot. Once again, I'm saying this is the this is a two lines plot with one single column of plots of images, and this will be the second plot. This will be the on the bottom, and I'm using SNS. That's why we import Seaborn. I'm using Seaborn here to do this plotting, to plot the labels and the probabilities. And by the end of that, what I get is this. So let's once again, at this time, let's take this doc image and see how well our model performs. So this will be my process image. As you can see, I'm using this I here and this I here, and I'm getting the two classes probability. So I just ran, we just did the prediction, and let's do the plotting to see how we went. So definitely a dog, and the model is telling us with basically, well, you can say 100% sure that this is a dog. And let's do it again with the cat. Let's just see the image, the plot works. I'm sorry, this code is nothing to do. I was doing something else. Don't worry. And we got the prediction. It's telling us that this is a catch. It's very certain that this is a catch. But there's a small probability that it may be a dog. The model is not that 100% true, but it's, well, we can say that it's sure enough to, so you can say that this is a catch. And once again, it gets the right prediction. And we did our job for the first part of the project. I believe this is the end of the first part of the project. Now we have to go move on to the command line app, and we'll be doing this right now. So this is the environment for the command line app. At first, you'll see that there's two images, there's two files open here, but there's nothing here. That's because it's mandatory that you. Sorry, what did I do? It's not supposed to happen. Sorry. Man, this is strange. That's very strange. So what you have to do, you have to come here and create a new file. This is mandatory. If you don't see a file here, that's because you're open with nothing. For example, I have this project file open here, but there's no prediction file here. So if I type anything and try to run, see, it just doesn't file. Although I can write everything, I can write in this file, it's not here, so it's not being saved. So you cannot use it. So if your file is not here, you have to create it. Train.py you cannot see here because it's not a real file, it's not created. So I have to create a new file, and I'll create the train.py. And when you first open, you have no terminals. You have to open to create a terminal. To open a terminal, you just gonna click here, new terminal, and now we have a terminal. And once again, you have to create the files, new file. You can even upload file, upload folder. I don't believe it's going to be useful for you unless you train your model and then you want to make a prediction on a file of your own, and you upload the file just to test. But basically, this is your environment, and you need to be. What you have to do, you have to create a train PY and predict.py, if I'm not mistaken. So now that I have created the file, I went here and created this string.py file. I can the file supposed to it's supposed to save automatically. I don't understand why it's not saving. Not saving. I'm gonna have to open it again. Yeah. and now it's saving. So be sure that this problem may happen, so you may have to reopen the file. It's not responding to your string. And this is how you run a program. You type Python, the name of your program. This is a Python program. When you give it enter. Now, what you have to do, you have to create these two files, string.py and project.py. And basically what you have to, these files to do is what's written on the documentation. There's explanation here. You have to create one file to train a model and save it, and one file to load a model and do a prediction on a given image that the user you pass through using arguments on the command line. I'm going to show you what these arguments are and how you can use them in just a little bit. Don't worry. But this is what you have to do. So basically, the deep learning part you have done by now. We have created all these all these functions to show the image, process the image, load the model, save the model, do training. Basically, what you have to do, you have to, of course, you have to do some modifications to these functions to accept the arguments that the user will be passing to you. But basically, what you have to do, you have to basically copy this function and paste it somewhere on one of those files if the function is required for training. For example, loading the train image. These transformations are required for training, so you have to paste it on the to use it on the application for training that you have built that you're going to build. So this will be on this train function, this train.py. What else? Defining a model. Of course, this is also used for training. So also on the train.py. So what else? This will also go on the train.py. Checking for accuracy also will be there. Doing the training, of course, is going to be there. This is the training itself. Defining the criterions and running this function will also be there. Checking for accuracy will be there. Saving the model will be there. And for the other and the rest of these functions will be useful. I want useful for prediction. For example, loading a model is useful for prediction. Useful to load the file that this train.py produce. So we'll be using this loading function, this process image and show, and the predict method and the location of the images. And this plotting, I don't know if you're going to do plotting, you have to read here. Don't forget to read this. Mhm. And you have to get all these arguments through the argument parser. So let's talk about the argument parsing. Well, what is argument parsing? Let me move back there. And let's me close these files. I actually created a file for testing for us. Well, this is the argument parser. It is a library. It allows you to pass arguments to inside the program, to be used inside the program from the command line. So to run this program right now, I can do this. So as you can see, I have three arguments, but I only pass one. So this allows me to use a string or a command that was given from outside of of the program inside the program. So we have these arguments that are going to be mandatory. For example, the data year. This data year will actually replace this data year. So what you have to do something like when you get the argument, you get the argument here. So basically, you have to run this line, and you get this argument star here, and you get this and replace it here. So what you have to do on this second part is almost only find where you have to replace. For example, where there is an optional argument, you can use if or if else to decide what you're gonna do. For example, there is an argument called GPU. It is called GPU. So the user pass this means the user wanna use the GPU. It's telling you to use the GPU for training. So what you can do is you can set an if else statement if true, which means that uh, this argument was passed. The training will be the model will have to be moved to the GPU. Although it may not even you may not even be using the GPU workspace, but you have to do, of course, to give you an error because you're not using the GPU workspace. But this is just for test, just for letting you know that this works. So the user passes you have use an if the user passes, you send the model and everything to the GPU. If not, you may choose how you can approach the situation. For example, you may choose to use the GPU which is available whether the user passed the argument or not, or or just send the model to the CPU. The user does not pass this flag. So I have compiled all the arguments for this first file. The first file you have to do is this training. This will be the first file that you have to implement the train, because of course you have to do the train before projection. So well, I want to make sure you understand that basically all of the functions are almost almost completely implemented. You have to do some small modifications to these functions. I can actually talk about this in the next webinar. We still have one webinar to talk about the second project. So the functions are almost all defined. You have to do some modifications to, for example, replacing this with the data gear that the user have to pass. This data gear is, if you look through here, this is the only mandatory argument, so it must always be here. If the user does not pass this, the program will crash, and this is expected. So you do these modifications to use these arguments, but if you look through this, you already have a function for checking for accuracy, a function to do the deep learning, to do the training. You already know how to define the criteria in the optimizer, how to do the training, how to save the model. We have a function for saving the model, a function for loading the model, a function for processing the image, a function for showing the image if it does require. I'm not sure if it is a function for doing the prediction, and you already know how to plot the classes and the image, as I'm showing you here. You basically what you have to do, you have to divide these functions, the ones that are used for training, the ones that are used for for predicting, and basically you have say least 70% of your project will be just splitting this function. So this second part of the project, of course. So one thing I want to mention, you always have to include these guys. Let me just copy them to these files. Otherwise the program will crash. Of course, it's not gonna be able to import PO by its own. You have to do the import here on the top of the file. And if you find strings, if name equals main, this is a common practice in Python to define the main function. So this is basically I'm defining the main function and writing code, all the codes that are here. Above here, what you have to do, and below this, here, you have to this is what this if name equals main actually indicates. This is the best practice for programming. So on top here, you're gonna define the function, define all the functions, basically copy the functions from here. This is not a function, so of course I'm not gonna copy here. Let's say, what is the function plus function? I have this function. And here define the function, okay, you use the function. And here you run also run code, so you have to do, we're gonna have to run code to pass it there. I hate this. Be careful with the indentation, otherwise Python is not gonna work. So you have to indent your code to the same place. So you have to be really well indented. I think you get the idea. But this is it. Of course, you also have to indent all of this code. But let's not worry about this right now. So this is what you have to do. You run and you're gonna, of course, you're gonna replace this with this little guy here, the directory that the user is gonna give you. It's gonna pass by the command line. So let's go on talking a little more about arc parsers. Now that you know what you do, that you know that below here you run code, and up here you define functions. So that's it. So as I was saying, you're gonna have to use these arguments that are passed from outside of of the of the program. You have this tutorial here, how to use the ArcPath module. This is a tutorial how to do this, but I have some sample codes. Let's go through the codes. First, you have to import the ArcParse. Is imported here. It's mandatory, and you have to define a parser. And all you have to do is we're gonna have to ask for adding arguments. So if you add an argument like this without these two dashes, this is gonna make it a mandatory argument. You can actually give some explanation. That's what you do with help. This help parameter is optional for adding the argument, but if you do, it is useful for the user to know what this argument means. So here we want the user to pass the directory where the data is stored. And if you when you want to give these optional arguments that the user can pass, you can use this dash dash to give, for example, save tier is optional. The user may or may not pass it. If the user does not pass it, you can save to the home, save it here to your home folder. If the user passes this, you're gonna have to use this argument to send it somewhere else. And we're specifying the type. The type must be a string. We are making the and if you pass, even if you pass a number, it will be interpreted as a string. You're not going to be able to add or multiply this number because it will be considered to be a string and not a number. And you also have this type of arguments, for example, using the GPU. As you can see, if the user passes GPU, I'm sorry, I'm using, no, much better. The user passes GPU, it's not going to tell you anything. For example, here the user passes hidden units and it gives you a number, but the hidden user just say GPU. So what you do, you use this start true, this action start true, because if the user passes GPU dash dash GPU, this is gonna be automatically set for true, and you have a true value. The user doesn't have to say that GPU is equal to true. So let me give an example on this program. So basically what I'm doing, if I don't, well, I say that this is a mandatory argument, and it is. Look what happens if I don't pass this argument. I'm sorry, this is not supposed to. You see something happen. See, it crashed because that is a required argument. But since I have not given it, yeah, it's gonna crash. Let's try it again. And you see, yeah, it takes a little because my connection to the server is a little bit slow, so that's why it takes a little, just a little bit of lag. I'm using this clear function to clear my terminal when I have all this noise. You wanna clear everything, just clear. This is basically command line arguments. So once again, let's try to run the program. Now I'm gonna give you the argument it requires, and we're actually gonna give you another argument, one of the optional arguments saves you. And I'm gonna say that save it to home, wherever home is. I'm sorry, I actually saying GPU. I forgot to add this. Sorry, now it's fixed. Sorry, I have to stop. See, it's gonna give you. And why is it giving me this false? Because I'm printing this GPU, and since I'm not passing anything, it's gonna assume that it is false. But look what happens when I pass the GPU flag. With the GPU flag, this is gonna become true, and this is what this sort true actually does. So it's really nice to is a really useful way to doing this the requirements. And so now you know how to use the argument parser, how to what you should do. You should basically split functions and do the modifications required for it to work in the way the specification is telling it to work. You have to define functions here. You have to write this. Don't forget to write this if name equals name. This is a good practice. Although the program would work without this and just align everything to the left of the screen. This is a good practice. So let's be sure to use this. This doesn't add much to the program. Just don't have to be mindful of anything by adding this. So this is just good practice. So, and you know that you're going to define functions here. You're going to run code here and run the functions also in here. And you know how to create these files. Create a new file, create train.py, create project.py. And this concludes our I believe, third webinar. The past webinar, you already have a way to implementing all the first parts. You have all the examples of the code you need. You have this predict function. You have this hotplot. Basically, have this predict function. You know how to plot. You know where to get the files, the file names. Just by going file, open, and plotting a little bit. You will have this process image function. You have a function for loading the model, a function for saving the model. So this first part is concluded. On the next webinar, we'll keep implementing the second part. So, but I believe you can do the rest on your own. If you're not, I'm always available. You guys know that. And once again, let me close this so we can stop sharing the screen. And once again, I'd like to thank you all for everything, for listening to the webinar, for taking the course. I mean, congratulations to you being independent learners, being lifelong learners. You're going to see that this will always pay off because on today's job market, if you don't develop this kind of sense that you have to pursue some difficult things, you have to pursue things that are meaningful. You have to pursue things that you have to keep learning, and may even have a degree, but of course, you have to keep your degree updated with the skills that people are willing to pay for. So, congratulations on already understanding that. I have a lot of colleagues that have not understood that yet, unfortunately. But that's not the case for you. Congratulations and thank you for watching. See you guys next time. If you need anything, you know what, you come for help. Thank you so much.